Hey, Benish here, talking to you about atoms, ions. Here we go. This is you. You might have learned that you're made of cells, but what are those cells made of? Well, there are things that are too small to be seen, but if we could break up that cell into tinier and tinier pieces, eventually we'd have the atom. The atom is the building block of all matter. Everything that has mass and volume is made of atoms. So, what does an atom look like? An atom has 3 particles. The first are positive particles, known as protons. There are also negative particles, called electrons. Particle doesn't have any charge, not positive or negative, so I'll put 0 charge there. These are called neutrons. We measure the mass of these things not in grams because they're so small that grams wouldn't even register. Instead, we register them in AMUs, atomic mass units. And in atomic mass units, protons and neutrons are both about 1, whereas electrons are pretty much 0. Not quite, but we can use 1, 1, and 0 for our purposes. Now, not only do we want to know the masses and charges of these, we also want to know where they are. So, in the middle of the atom, we've got some protons, and we've got some neutrons. We call this center of the atom, that sort of is in this area, the nucleus of the atom. And the nucleus has by far the most mass in the atom. As you saw from the previous slide, since it has all the 1 AMUs, the protons and the neutrons, and since electrons are pretty close to 0, most of the mass is going to be in the nucleus. It's not most of the volume, though. So now this part of the drawing isn't to scale, it's important to note. But in the middle here, I've got my nucleus. And outside of the nucleus, we have electrons. And sometimes when we're just learning about these, it's easiest to think of these electrons as flying around in kind of an orbit, like planets around the sun, even though that's not really what electrons do. It's a model that helps us to understand and learn. So the nucleus, right in the center, has most of the mass. We've got electrons hanging out far on the outside. Another thing you need to know is that different numbers of protons make different elements. So when I have 6 protons, that's carbon. 1, 2, 3, 4, 5, 6 neutrons, doesn't make a difference. The 6 protons make a carbon. Now, carbon symbol is C. Next, let's talk about mass number. If I count all of these particles in the nucleus, protons plus neutrons, I get the mass number. So here I have 6 of each, so the mass number for this carbon is 12. So I can write it like this, carbon 12. So what atom am I making here? 1, 2, 3, 4, 5, 6. If you said that that's also going to be carbon, you're correct. So this time I'm going to put in neutrons. 1, 2, 3, 4, 5, 6, 7. That means that since I have 6 protons and 7 neutrons, this mass number is 13. So these are both carbons, but they have different mass numbers because they have different numbers of neutrons. When we have this situation where we have the same number of protons but a different number of neutrons, we call these two atoms isotopes. They are isotopes of each other. In each of these atoms, we've got one proton in the nucleus and no neutrons. One proton tells us that we're working with hydrogen. It has a symbol of H. And the mass number, these are both hydrogen 1s. For now, though, let's just forget about the mass number. In each of these cases, we see that since we have one positive proton and one negative electron, we have neutral atoms. The +1 in the center and the +1 in the electrons, they cancel out, leaving 0. But sometimes what happens in an atom is that it can get another electron. So in this case, we've got a +1 but -2. So overall, this atom right here has a -1 charge. It is called an ion when it has a charge, either plus or minus. So I write it like this, H minus. I could write H -1, but we know that if it says minus, that just means 1. If it were -2, I'd want to write the 2. So this represents an ion, and since it's negative, we call it an anion. So another thing that can happen is that an atom can lose an electron. So if we look at this on the bottom here, right now it's neutral. We've got a +1 and a -1, so it balances. But let's see what happens when it gives up this electron. Now it's got a +1 charge, but there's no negative charge. So overall it's got a +1 charge, so this is going to be a H+ ion. And since it's positive, we call it a cation. To recap, here's what we learned in this video. Atoms are the building blocks of matter. Everything is made of atoms. Atoms are made of 3 different particles. 1, protons, which have a positive charge and have a mass of 1 AMU. Where do the protons live? In the nucleus. Protons live in the nucleus next to the neutrons, which have 0 charge and have a mass of about 1 AMU. Neutrons and protons really don't have exactly the same mass, but for our purposes today, 1 AMU. And they also, like we said, live in the nucleus. And last we have electrons, which have a negative charge, about 0 AMUs, and they live in a cloud outside the nucleus, well outside the nucleus. We also learned about isotopes and ions. Isotopes and ions are designations we give to atoms in certain situations. Isotopes are, examples of isotopes are hydrogen 1 and hydrogen 2. We count the mass number to identify isotopes. And remember, mass number is number of particles in the nucleus. 1, 1, 2. So when you have the same number of protons, but different numbers of neutrons, those are isotopes. Ions are charged atoms. And in fact, we often don't even call them atoms. We just call them ions. Like lithium +1 or oxygen has a -2 charge. So those are ions when they have positive or negative charges because they gain or lose electrons.